Hi there, this is Penelope. This is a video on integration, and it's integration where you would probably previously have thought you could do it with substitution and algebraic substitution, and you can, but some of you are clearly having difficulty with using algebraic substitution. So what I'm going to do in this video is show you some techniques that perhaps allow you to get beyond having to use substitution, at least for the easier ones anyway. So what we've got is that we know that if y equals the natural log of some function of x, then the derivative is equal to the derivative of the function divided by the function. So more or less, then we can work in reverse. Then the integral of that, so just going backwards because integration does, is equal to the natural log of the absolute value. Now we just have to put in the absolute value there because there might be some negative signs that mess us up, but more or less we can do that. Okay, let's have a look at an example where we can and it works. Okay, what we've got here is we've got 2x plus 3, and if we look at it carefully we can see that it's the derivative of x squared plus 3x plus 4. So we have that pattern. We have the pattern where we have the derivative over the function, like that. So using the rule, then the integral of 2x plus 3 over x squared plus 3x plus 4, because it fits the pattern, is just going to be straightforwardly the natural log of the bottom line plus c. And you can check that, you can go back. But if it isn't quite the derivative, but almost, then we might need to do a little bit of tweaking. Now you know the rule that allows us to take that 4 outside, so we can already write it as 1 over 2x minus 1. And then it's almost what we need, but not quite. Let's leave the 4 there. And then it's natural log of 2x minus 1. But if that were the case, then we'd have a 2 on the top. So we need to divide by 2 or multiply by a half. Could divide by 2. And then we'd get 2, put my plus c, we'd get 2 natural log 2x minus 1 plus c. So that's just a little bit of tweaking. The next one will be the same, and you'll be able to see it really works very, very quickly. We'll take the 20 out. And then we can say the answer is going to be 20 natural log 0.2t plus 1 divided by 0.2. But we're not going to leave it with 0.2 on the bottom. We're going to do the division. 20 over 0.2 would be 100 natural log. That creaking noise you can hear is my cat walking on all papers on my desk. Okay, so there's a pattern. If you've just got a number on the top, you can fiddle with that number to make it all kind of work. Now though, we've got something different. This obviously isn't one of the examples where we have the derivative of the bottom line on the top. So we need to do something else. Now you can see that we can simplify that first, and we can divide everything by x squared. So then we've got 2 over x cubed, x squared. We can cancel the x's, and then we've got x squared over x cubed. Actually, maybe we'll do it so you can see exactly what I'm doing. And then that becomes the integral of 2 over x squared plus the integral of 1 over x. Now each of those is integrable, because we could rewrite that as 2x to the negative 2 plus 1 over x, because that's a special case, we know about that one. So then it becomes x to the negative 1 over negative 1 times the 2 that was there, plus the natural log of x plus c. And whether or not you want to tidy up that 2 over x plus natural log x plus c, that's fine, you don't have to. I need to put a negative sign there. Now here we are, back to that pattern again. If we look closely, it's like the pattern. The derivative of the bottom line is on the top. So we can go straight to the answer and say that it's the natural log of the bottom line plus c. And you can check that out. Check it out by differentiating back. Okay, so this is equal to if it's got the integral on the derivative on the top over the function, then it's natural log of the function. That's just what we've done. This one though, it's not one of those. It's quite different. Top line, not the derivative of the bottom line. So maybe we just need to do some simplification first. Okay, so let's have a look. Can't do anything with the top line, but on the bottom line, yes we can. That's equal to x plus 2 times x minus 2. And even before we've integrated, we can simplify, and now we've got the integral of 1 over x minus 2, and that is the natural log of x minus 2 plus c. So there we had to do a little bit of sneaky simplification first. The last one, no factorization. It doesn't fit the pattern. Doesn't fit that pattern of the derivative over the function. So that's one thing. There's no factorization. So what we've got to do is something else. What we could do is we could divide the bottom into the top and break it down that way, as we did on slide 7, though slide 7 works. This one needs to be done a little bit more carefully. I'm just going to write it back to front. 2x plus 1 over into negative 2x plus 1. 2x into negative 2x goes negative 1, multiply it, negative 2x minus 1, subtract 1 minus minus 2 is 2. So our original question then is equal to the integral of negative 1 plus 2 over 1 plus 2x. That's just long division. Now though, we can integrate. Integral of negative 1 is negative x, and the integral of 2 over 2x plus 1 is now one of those patterns. It's the derivative of the bottom over on the top. So it would be just natural log of 1 plus 2x. And you might feel that it would be nicer to write it in that way. Right, so that just might help some of you who are struggling with some of those substitutions. Those are quicker ways of doing it.